in this question, a constant force F naught is applied on a block, and block is moving from 0 to 100 meter. Now see what they want to ask in the question. In the question, it is given that the change in kinetic energy of the block when it moves from x equal to 0 to 50 is delta k1. Change in kinetic energy is given, and for the distance 50 to 100 the change in kinetic energy is given k2. How does delta k1 and delta k2 we can relate, compare? So go back to the question. Because for 0 to 50 we can say work done equal to change in kinetic energy k1, that is w1 work. The point is that the force is constant, no other force is acting on it, only in horizontal direction there is a one force F0. So you can say force into displacement is 50, that is delta k1, because work done equal to change in kinetic energy. Similarly for 50 to 100, again we say work done in part 2 equal to delta k2, and we can say w2 equal to f0, because f0 is a constant and distance is again constant. So by these two equations you can compare that delta k1 is equal to delta k2. If you want to calculate the change in kinetic energy in the whole journey, if the particle starts from rest, then you can say for whole journey w equal to delta k and work done equal to f naught into total 100 equal to delta k. So delta k is twice of delta k1, or you can say twice of delta k2. So similarly you can say for moving from 0 to 50 and moving from 50 to 100, the work done is same. Okay, so the answer is the delta k2 delta k1, because the applied force does the same work, correct? Because work is not equal to kinetic energy, work is equal to change in kinetic energy. So change in kinetic energy will be the same because work is same. Now move further. In this question, a velocity time graph is given, that is data interpretation or transaction between graph to a numerical understanding through the graph. In this question, the car is start from t equal to 0, and for some time its velocity is constant. After that its velocity is decreasing, but the decreasing with non-uniform acceleration. If the graph would like that, then we can say the velocity is constant and acceleration, or you can say retardation, is constant. But in this case there is a curve, so the slope of the curve is changing, and you can say the slope is also decreasing. The slope is also decreasing. If you draw the tangent in that curve at different position, so you will find out that slope of that tangent is decreases. And the VT graph, as we know, in the VT graph, slope represent acceleration and area represent displacement, or you can say distance and displacement. So now we move on the question. So in the question, the position of the car at time t and 2 and 3. First important thing, that in the time duration in 1 second, total 2 second, in total 3 second. Sometimes student got confused that distance travel in second, in third second, first second. It is not like that. It is total 1 second, total 2 second, and total 3 second. x1, x2, x3 respectively, which of the following correctly rank x1, x2, x3 greater to least? Obviously it is simple question that the velocity is decreasing, but it is particle is not changing its direction. For example, velocity is decreasing because the acceleration is type of retarding type, negative, opposite to the direction of velocity. So if the particle direction is same, the particle is not changing direction, because direction of velocity is not changing in the graph, but the speed gradually decreasing, but the particle move in forward direction. The particle, for example, in 1 second I am moving with the speed of 10, next 1 second I am moving with the speed of 5, but I am adding on, I am adding the distance. So distance always increases. We can also interpret with different concept, because the VT graph gives the area. Obviously, as we move further, the area is increasing, 0 to 1 and 0 to 2. So 0 to 1 is area is that, and for 0 to 2, the area and the VT graph is complete this, and for 0 to 3 the area also include this. So the if we calculate think by area, that area give the distance and displacement VT graph. So as you move from 1, 2 and 3, so area of the graph is increasing. So we can easily say that distance travel in x3, then x2, then x1. So simple question, the translation between graph and numerical value. So further, so that is a simple question of you can say kinematics. Thank you.